In the last 5 years, if you look at the total losses in lunar missions due to navigation, the cost is at 350 million. You extrapolate the same failure rate across the next 8 years of lunar missions we currently have planned, you're looking at $19 billion in losses. So that was the kind of the big number that was like, okay, well, this is clearly a problem that needs solving.
We take GPS a bit for granted here on Earth. We always know where we are. If you are a lunar lander, for example, and you want to know where you're headed, where you're going to land, you need to rely entirely on your own sensors. One of them fails, it can propagate and make the whole system fail. And now that we see more and more landers, it's more and more important that a proper navigation system is introduced to guide them all to the right landing spot.
Imagine a pilot flying an airplane without using GPS. No air traffic control, just the pilot trying to figure out where they are based on landmarks. Now imagine doing that on the moon where there are no runways, no navigation beacons, and where getting lost could mean a mission failure costing hundreds of millions of dollars. This is exactly the challenge that lunar landers face today. In the past few years alone, we've seen multiple lunar missions crash during landing attempts. In today's episode, I talk with Ashwin Iyer and Alex Pinel, the co-founders of Instinct. Instinct is a startup building the first navigational satellite constellation to provide GPS around the moon. Let's dive in and explore how they plan to solve one of the most pressing challenges in our return to the moon.
I'm Ashwin. I'm the co-CEO of Instinct. I'm a graduate out of the University of Cambridge, previously a manufacturing engineer and a manufacturing consultant. I've worked across metalworking, electronics, venture capital, aerospace, working on Rolls-Royce jet engines, and now I'm here.
Perfect. And I'm Alex. I'm also co-CEO. I'm an aerospace engineer with a master's in space science and engineering from UCL. And I have experience working in project management at Open Cosmos, a CubeSat startup in the UK, which has successfully launched quite a few CubeSats already into low Earth orbit.
And tell me what you guys are building at Instinct.
We're building a navigation constellation around the moon to enable GPS-like services for companies and government entities orbiting around and landing on the moon.
So let's peel the layers back a little bit, right? Explain why navigation around the lunar space is such a challenge today. What makes finding your position on the moon so much harder than it is on Earth today?
There's a ton of factors involved. Lunar orbits, for example, are very unstable compared to orbiting Earth. There's mass cons and gravitational influences from the Earth. So just being in orbit is already very difficult. But then there's plenty of other factors that right now we take GPS a bit for granted here on Earth. We always know where we are. But if you are a lunar lander, for example, and you want to know where you're headed, where you're going to land, you need to rely entirely on your own sensors. So your inertial measurements, your gyroscopes, etc., etc. And well, it's very difficult to get that to work properly, or if one of them fails, it can propagate and make the whole system fail. And now that we see more and more landers, it's more and more important that a proper navigation system is introduced to guide them all to the right landing spot.
Yeah, I mean, in terms of the numbers we quote a lot is in the last 5 years, if you look at the total losses in lunar missions due to navigation, the cost is at 350 million. You extrapolate the same failure rate across the next 8 years of lunar missions we currently have planned, you're looking at $19 billion in losses. So that was the kind of the big number that was like, okay, well, this is clearly a problem that needs solving.
Yeah, your comments are very topical, especially of the news today, right? There have been a lot of challenges with a lot of commercial landers just in the past few years, including the events of this week. Firefly was successful, but the vast majority of them have really struggled with respect to navigation on the moon. But I want to go to like the big government agencies, right? Like the NASA, the ESAs, who have had a lot of experience landing on the moon. They seem to be working on a lunar GPS initiative, but how do their efforts compare to what's going on in the private sector?
So we know that ESA is working on Project Moonlight. We actually had a meeting with them yesterday morning to talk to the head of Project Moonlight about how we could collaborate in that ecosystem, how we could get up there faster and provide extra coverage and enhance the accuracy of their systems. And, because I think they're aiming for 50% coverage by 2028. We aim to get into orbit and provide around 80%. by the end of 2026. So we're really looking at it from a collaborative standpoint of how can we make going to the moon easier for everybody involved, right? We don't see it as a competitive endeavor. And I think NASA sees it the same way. They set up LunaNet in a way so that we could have collaborative ventures up there between companies, governments. The end goal is we want to explore the moon and make life better for everyone down here, right? Whether that's through mining, whether that's through manufacturing up there, whatever it is. So for us, it's just, we think it's a new frontier. We want to make it easier to go there.
What are the gaps that exist that the government sector is not filling right now that the private sector, like Instinct, is aiming to fill?
I mean, I guess our approach is far more nimble. I don't know if that's the best word to use. We're relying on CubeSats, so we can get there really fast and cheaper. So we can, whereas big projects that involve bigger and fewer satellites, maybe you can provide like higher levels of accuracy perhaps, but we want to be there as fast as possible. And because our approach is so flexible, we can set up satellites in different orbits around the moon and eventually provide coverage for the whole moon rather than just this particular part or that other part. So we can provide more satellites quicker and cheaper and quickly build up a full constellation around the moon.
Yeah. And I mean, when you're kind of transitioning into the next age of, we're kind of starting to see a lot of competition now between the US and China, for example. You need resiliency in your systems. One of the big fears right now is that we know that, for example, China has the technology to move satellites in orbit. So the government is really pushing for more resiliency in its networks, especially in the GPS networks, right? So we're not solely reliant on these satellites that could be moved out of orbit and then take out our entire PNT network. So our satellites provide that. They provide resiliency in the moon and in the future for whatever else. And a more resilient system is better for everyone.
Why is it taking this long?
The research on it is fairly new. I mean, some of the stuff we're using was like research just a couple of years ago. Some of the stuff you see the amount of traction going to the moon, and it's fairly recent. We saw quite a bit of activity in the last 5 years, but in the next 8 years, especially, is when we see it ramping up, and the impetus being, partly political with the competition between the U.S. and China. We think it's fairly recent that this big race to the moon has begun.
What's the most challenging part about like going to the CubeSat architecture from, say, the large mega class size satellite bus architecture?
Of course, I mean, going to smaller satellites involves miniaturizing pretty much everything. So from power, of course, regarding GPS satellites, atomic clocks, etc., etc. But I mean, we have seen the success of CubeSats on Earth, and we have seen already quite a few CubeSat missions going to the moon. So we know that this is possible, and that's one of the main reasons we have decided to focus on the CubeSat architecture. It's a standard form. We know it works. We can send it to the moon.
So it's a breadloaf sized satellite, right? For those who are unfamiliar with the 6U architecture, it's a breadloaf sized satellite. What's the average lifespan of one of those in a lunar orbit?
So, of course, lunar environment is quite different from low Earth orbit. For example, radiation plays a bigger impact. We're aiming to have them there for at least 5 years and then see how long they last afterwards. But once more, because they're cheaper and easier to build, if one fails, we can afford to send another one and build up the constellation. And once the lifetime of one runs over, we can just send another one to replace it very quickly.
Let's talk about like the activity on the moon and the lunar economy as we see today. There are lots of companies that are aiming to mine, say, helium-3 on the moon. There are companies that, like Starpath, they want to create propellant on the moon for refueling, say, starships, things like that. With these kind of companies in mind, who would be your target customers?
So our target customers right now, the big list we go off is the Commercial Lunar Payload System, the program CLPS, CLIPS. That's a big list of companies that NASA started contracting now, developing that lunar economy. From there, companies like Interloon who are looking to mine on the moon. In the future, we think there's going to be manufacturing on the moon, right? When you think about what you need to escape Earth's orbit versus what you need to escape lunar orbit, it just makes sense to start manufacturing rockets on the moon at some point. So in the future, we think there's going to be, an economy around manufacturing and, like you said, propellant refueling around the moon. So those will be our customers in the future. Right now, CLIPS program and then helium-3, I think very near future.
Yeah, so let's dive into that a little more, right?
Yeah.
What in terms of having GPS capabilities around the moon, what specific opportunities does that open up in the near future?
Beyond, of course, just landing, pinpoint where you want. Let's say you are using rovers to automatically go to this particular target to scout for some minerals to mine, for example. Or let's say you've landed astronauts in the moon, they need to go inspect this particular area. But as the lunar economy develops, we will see use cases far more advanced and perhaps one day, sooner than later, very similar to what we see on Earth of actual infrastructure that relies on actually going from this point to that other point. Or we're mining resources here. We need to take them to this particular depot or something like that.
Yeah.
Send them over to Earth. So everything from satellites orbiting the moon, from the landers, from the people, from the robots, everything will need some sort of GPS capability.
Thinking more short term, like, of course, landers, we want to disable that 23% failure rate due to navigation, right? That's a massive block in the funnel that we're removing there. And you also massively reduce the costs of landers because currently, for example, this is all public information, Blue Moon landers, they use like 2 LiDARs, 2 million each, and then that 20 kilo payload for those LiDARs just for navigation. That's a total 20 million in cost just for navigation. So we can reduce that drastically with a 500-gram GPS receiver module. And satellites in orbit around the moon as well. Most lunar orbits are unstable. So having your position more accurately allows you to calibrate your orbits, stay in orbit around the moon longer.
Because, of course, we know that prices of kilogram to low Earth orbit, for example, keep going down and down and down. But, of course, comparatively, sending a kilogram to the moon is very, very expensive right now. So, although all that mass that is spent on navigation equipment and redundancy, if even half of it could be cut down, that's payloads that go to the moon, that's cost reductions for the landers, and it just makes the whole lunar economy right now far more affordable. It's far easier for, let's say, a rover company to say, okay, can I buy this slot to go on your lander?
Okay, so that's well and good. But let me ask the basic question. How do you plan to make money with a lunar GPS service?
So we plan to charge our customers on like a yearly annual basis. So we sell them the receivers and then we sell them access to the network. Of course, we're still workshopping on pricing. That's going to depend on once we have that, our demonstrator satellite, which we're launching in October, up there in orbit. Once we have that up in orbit, then we start, making a lunar satellite, and then we start getting contracts for, how much we can charge a rover versus a lander versus a satellite in orbit, and yeah, so fully commercially.
How is that going to play out, you think, with respect to different types of customers when it's a commercial customer versus a government customer?
There's definitely the possibility there for government contracts for longer periods over the US, the EU, whoever else. We haven't really thought about how that business kind of plan will be different based on those two customer sets. We're mainly looking at commercial right now. I mean, for the first time in history, 51% of missions to the moon are commercial right now, booked over the next 8 years. So that's a massive stepping point. And with the way NASA is functioning right now, we think that number is, if anything, likely to grow. So yeah, we're mainly targeting the commercial market for now. But of course, there's a space for expanding into government later.
Yeah, I was going to say, precisely, I was going to mention that 51% number as well. I believe that's from an article in the Financial Times. And I think everything right now indicates, especially with the new administration and the way NASA is going right now, that they're probably going to lean more and more on commercial partners to deliver payloads to the moon and establish that lunar economy. So, as Ashwin said, we right now are not looking at the government and commercial sector as particularly different from each other. We're treating them more or less as the same, but we anticipate that most of our customers will be commercial companies.
So how do you plan to scale up the entire architecture of your satellites? You're starting with 4 satellites in lunar orbit, if I'm not mistaken.
Yeah.
How are you going to scale from your first 4 to achieve full coverage around the moon?
So 4 satellites in 2 particular elliptical orbits gives us uh, partial coverage of the lunar south pole. So as lunar economy grows up and more landers go, we of course will. It's a matter of just sending more satellites to different orbits, and once you've done that, you can provide coverage over the whole moon. So, with let's say 4 satellites, we provide partial coverage. With around 6 to 8 satellites in just those 2 orbits, we already provide constant coverage over the South Pole. And if we double that, we would have coverage over the whole surface of the moon.
And technically speaking, I saw it's a frozen elliptical lunar orbit. I kind of know what that is, but I'd love for you guys to explain the benefit of that orbit.
So the moon, compared to Earth, orbiting the moon is really challenging. There's this things called mass cones, where like I suppose you could describe it as some parts of the moon are more dense than others, and that has some weird impact on the gravity of objects orbiting around it. So it's really hard to predict where a satellite will be in the moon. And also, of course, the moon is a small body, then you have the Earth also having its own gravitational pull, kind of like the tides on the oceans on the Earth. So finding an equilibrium of an orbit around the moon that is stable and you can understand very well and it won't move around in unpredictable ways has been quite challenging. But now it's known that there's this highly elliptical frozen orbits that if a satellite is placed there, it will just stay there and will require very little station keeping. In another orbit, if you're orbiting in low lunar orbit, it's very likely that you will have to spend lots and lots of fuel and delta V just to stay in that orbit without drifting away.
You talked about some of the challenges there. We talked about the orbital challenges. We talked about the challenges of miniaturizing what is typically large navigational equipment into a small 6U CubeSat form factor. Talk to me some of the other technical risks and logistical risks of deploying and operating a navigation system around the moon.
One of the things that keeps us awake is probably the whole communications aspect of it, right? Having a CubeSat. We know that CubeSats have taken to Earth even from Mars. I think it's the Marco missions that were sent back in 2018. But it's still challenging, right? We need our GPS transmitter to be pointing at the moon. We need our solar panels to be pointing at the sun. And then we need some communications pointing at the Earth. So that's a three-way pointing requirement on a single object. And figuring that out it's a weird puzzle.
So why do you need Earth reliance in this loop, though? I thought the whole idea was to eliminate where we currently use Earth reliance, right? Like all of the landers, like IM-1s or the Hakuto R missions, there's some amount of communication with DSN. How do you can you build a truly isolate system that doesn't rely on Earth?
I believe so. Yeah, maybe. I mentioned communication to the Earth mainly on focusing on telemetry and just like station keeping and being aware of the health of the satellites. But yeah, communicate with the Earth. If as more and more satellites go to the moon, I think the whole system will be self-reliant, and you shouldn't rely on Earth GNSS. But we've seen experiments like Lunar on Firefly Blue Ghost that have successfully proven that you can use spillover GPS signals from the Earth. And that's really handy as well for when it comes to calibration, clock synchronization. There's multiple things that can be used for.
Is there like a particular area of the moon that is easier to solve for in terms of providing reliable navigational data versus other parts of the moon, say like the South Pole or the equator?
So we're mainly looking at the South Pole right now because that's where most of the missions are headed, right? You go where the market is. If, for example, humanity spreads out and decides to start landing a lot on the north side of the moon, then it's pretty easy and kind of the same-ish orbital mechanics to get our satellites in the alternative L4 orbits targeting the northern side of the moon.
And does that essentially mean that you'd have to change the orbital plane of the satellites?
We'd have to launch more satellites to get them into the other orbits.
Yeah, we're not planning to move the satellites already in the moon around, but just launch more satellites into different elliptical orbits, and that way we can provide the coverage.
So navigating the business side obviously has to have a lot of challenges in its own here. What's the current state of the regulatory side of building a lunar GPS?
So, I mean, one of the biggest things that NASA has done, like I mentioned a little bit earlier, was I think this is their big expansion since moving into the new space economy, right? So LunaNet is this massive gift of this, hey, follow these regulatory laws, follow these frequencies, do this for if you're doing this use case. And we're building ourselves from the ground up to be compliant with LunaNet so that we can slot into that infrastructure, so that we can skip over as much regulatory red tape as possible. And, we've been to quite a few conferences while we've been here in San Francisco, around the US as well. And all the talk is about eliminating as much red tape, regulatory red tape as possible, especially with this current administration. So we're hopeful. We're hopeful.
It's true. I've heard the term of like Wild West regarding low Earth orbit right now. And if low Earth orbit is the Wild West, then moon orbit right now is kind of like unexplored territory in terms of regulations as well. So they are in the works right now. I think there was a talk in Congress just a week ago about what's exactly the plan with the moon, stuff like that. And e- e- everyone seems to agree that the best way to do it is to kind of replicate the success of the commercial model on low Earth orbit on the moon, allow companies to establish a presence there.
Yeah.
Do you currently see that the frequency assigned spectrum with LunaNet is that sufficient in terms of its bandwidth, or will you need eventually more?
Currently, it seems sufficient by our calculations.
You've got GPS around the moon, right? You're successful with that. Let's say you're successful with that. Can this technology be applied beyond the moon?
In theory, yeah. I mean, nothing prevents us from getting our navigation payload onto satellites that, let's say, will go to Mars or somewhere else. That introduces plenty of different problems we haven't even started to think about. But in theory, yeah.
We can use a similar network architecture that what we're doing to set up navigation systems on Mars early. If we start pushing there, for example, one of the big things is we're currently on a 6U CubeSat form factor. If the lunar economy really does grow, in the way that we want it to, then you scale that up to a 12U and start adding whatever other services people on the moon need. Whether that's imaging, comms, space awareness, whatever else.
And does this need to remain in a CubeSat form factor? Does it need to grow bigger? Can it grow bigger?
It can grow, but of course we are a startup, and we think it's strategically it's the best move to follow the CubeSat form factor, both in R&D terms and just cost terms using rideshares. It's just the simplest, most reliable path for us to follow right now.
Say you have a situation around the moon where you're getting so much demand. Is the idea to simply launch more 6U CubeSats to sort of slot in and offset that demand, kind of like you can with Starlink, where you put in more satellites out there to improve coverage? Is it as simple as that, or is there scale factor involved in the satellites themselves?
In theory, it's even simpler than that because, in principle, GPS or GNSS, the way it's established, is a passive system. We're transmitting a signal, and it's on the end of the receiver to pick up the signals from different satellites and then compute a position. So the satellites are just transmitting. So it's not really a matter of like the bandwidth and how much can be allocated to each target, for example. As long as you have a receiver, the system should work.
I just realized that, like, when I was looking at the elliptical orbit and we were talking about GPS and GNSS, GPS and GNSS are stationed so far up where it's essentially a stationary point in space, right? Lunar frozen elliptical orbit is not. So you'll have swaths of eclipses. How long is that eclipse duration?
So it's very similar to Molniya orbit on Earth, where because it's highly elliptical, you're actually spending most of your time actually in clear sight of the target, in this case, the South Pole, and then just it's a brief period of time that you're actually on eclipse behind the moon. So it's just going to be a few hours at most. And again, once we have more and more satellites, the coverage will be constant anyway.
So the initial Pathfinder satellites will, say, have a dip in coverage or some downtime to account for their eclipse condition.
Yeah, we'll have partial coverage with our first constellation, but once we get to 6 to 8 satellites, we have 100% coverage with some redundancy in there as well.
Mm-hmm. What was the process of applying to YC? How is that for you as a space company? And ultimately, if you were to pass advice on to another space company, what advice would you give them?
I think it's what helped us was just we went and saw the biggest problem that we could try and find a solution to. We just started building. We're all engineers or physicists, and it was just really fun for us, even without the idea of getting into YC or anything, to just try and build a solution to a problem. That's eventually what landed us in YC. With the idea we were working on at the time, we had prototypes already. We applied with that, and yeah, I mean, our group partner liked us, I guess. Yeah.
I completely agree with Ashwin. We applied, but we were determined to keep going regardless of what was going to happen. So we're like, we're dead set on doing this. And well, thankfully, I guess YC saw some value in us, and well,
Yeah.
that's how we landed there.
How big is your team today?
It's just four of us. That's a big thing we learned from founding that rocketry society, was that you actually get a lot less work done by getting a lot more people in, because 100 people, not that many of them were actually doing really good work. Our interview process wasn't great in university,
That
right?
relates to YC's advice of doing things that don't scale.
So it's four founders. We keep the team lean, and of course, all of us are technical. We all do the work together.
Yeah.
It works amazingly for us so far.
And there's a clean room in San Francisco, if you believe it.
Yeah.
Well, okay. So here's my final two questions for you. Instinct is successful. You have a thriving lunar economy. You have a service that provides precise navigation on the moon and around the moon. How does that change the future of space exploration in your view?
Well, I think, of course, the biggest goal is to make exploring the moon easier. So if you make exploring the moon right now as easy as going to low Earth orbit, you look at the major economic incentives that low Earth orbit has, the ways that it's helped the economy back on Earth. Lunar economy can help us in the same way. If it's really easy to bring helium-3 back from the moon to the Earth, if it's really easy to set up a transportation relay to the moon and then launches from the moon to wherever else we need to go, deep space missions become a lot easier from there. There's refueling depots on the moon. Like, we'd love for it to become a hub of activity, basically.
Yeah, I was gonna say that if assuming we're successful and everything goes well, I think the goal is to be so essential to the lunar economy and everyone going to the moon that it's almost taken for granted. Oh, I'm designing a lunar lander. Oh, where does the instinct receiver go? Oh, yeah, it's here, of course. You think I didn't think about that?
My final question to both of you guys, and I'd like both of you guys to take turns and answer. You're taking a contrarian bet with Instinct.
Mhm.
You are designing, you've seen this gap in the market where there needs to be a lunar GPS, and you've decided, hey, nobody's thinking about this. We got to go think about this, and we got to go put some hardware out there. Besides what you're building at Instinct, what is a contrarian bet that you're seeing in the industry?
I mean, of course, there's lots of wild things going on in the space industry nowadays. And I guess Leo in particular, maybe I'm speaking a bit too soon, but it has a feeling of it's becoming an established thing, more or less, to be a commercial company in low Earth orbit. But I mean, there's companies taking big bets. Astroforge comes to mind, for example. They're forging ahead to start mining asteroids, and yeah, there's a few companies out there that are taking big bets. I suppose we're one of them. That, like, if this works, it's big rewards. It's something essential, something that will bring huge benefits to everyone. So yeah, I think Star Cloud as well, data center. So
I mean, for me, I might also take the opportunity to plug some more YC companies. Just in our batch orbital operations, for example, I mean, making high thrust orbital tugs in space. You see the designs that they're working on, the crazy solutions they have to, fuel storage or, fuel generation in orbit. It's insane. I mean, they're building a lot of it from the ground up, but I think something that the CEO of Astroforge told us when we had a call with him was, in this industry, you either go balls to the wall and try to make it and hope you land, or you just falter away.
Yeah, I've met Matt Galick a couple of times. I remember him telling me, you got to take outsized risk as a startup.
Yeah.
Otherwise, what are you doing?
Yeah.
Exactly. And I completely agree. Yeah. We want to do this. Let's give it all we can. And well, I believe we'll pull it off, but I cannot deny
Yeah.
that there's risks involved, right?
Or at the very least, we get to say we gave it our all, right? I mean, Matt, we talked to him kind of early on where maybe we were a little bit too risk aware. And he just told us, like, yeah, I spent our entire YC investment before demo day because I want to do something. I was like, damn, maybe we should do that. And we haven't done quite that, but we've done a lot of that. Booking our launch already, for October on Transport 15. Like, it's a huge risk, but we're going to be ready and we're going to rise up to the challenge.
Yeah. If we want to do this, it's what we need to do.
Yeah, Matt is a great mentor to have. I
Yeah.
100% attest to everything he's doing at Astroforge.
Yeah.
Guys, thank you so much.
All right.
It's been such a pleasure to talk to you all. Really wish you guys success. And I think you guys are going to do great things with a successful deployment on Transporter 15.
Thank
Lovely.
you.
Thank you so much, Anurag.